Good morning. So this is number 12 from section 3.3, and we're asked to use row reduction to calculate the inverse of this matrix. So notice this is a 4x4 matrix, so a little bit bigger than the ones we did in class. But the method is still the same. So in order to find the inverse, we're going to augment this matrix, this rather large matrix, and add to it an identity matrix. So I'm actually just going to edit as it's written right here. So I'm just going to erase this for a second. So what we're going to do to this is draw that vertical line, and maybe I'll do it in a different color to make it obvious. And we have an identity matrix. So ones on the diagonal and zeros everywhere else. And our goal here is to use row reduction to change the left-hand side into an identity matrix itself. So to make the left-hand side look like that right-hand side. So there's a couple things I might notice here. You might say, for instance, well, there's no element in this column right here. And so if it were me, I would likely rearrange some of these things so I can get a 1 right here. I might also notice that this row is already really set up to look like that third row. So what I could do is switch some rows around. So in order to do that, I'm going to switch those two middle rows. And let's just have that be a step. So the top row I'm going to keep the same. I'm going to switch the two middle rows. So I'm going to make this one row 3. So 1, 1, 1, 0. And this becomes on the third row on the right hand side, and then switch that out with 0, 0, 1, 0, 0, 1, 0, 0. You have to be very careful with the order of these numbers. 1, 0, 0, 2. Okay, so that's really just switching the two middle rows around, and I think that makes this one a little bit nicer. So what I need to do now is go for a 0 here and here. So maybe I'll change colors. So I'm going to again leave the top row as it is. I'm going to take, in this case, row 2, and I'm going to subtract off the top row, which will give me a 0. 1 minus 0 is 1. Plus 1 is 0. And I am going to introduce an element on the end here, which is fine. It's not the best, but so this 0 becomes a negative 1. So we just did row 2 minus the top row, so we get negative 1, 0, 1, 0. Now for this next row, I'm going to do something to it. Well, I mean, so the next row I will leave exactly the same because it's beautiful and perfect as it is. But for the bottom row, I want to get rid of this 1. So I'm going to there take that top row and subtract it from the bottom row. So this is going to be row 4 minus that top row, which gives me a 0 here, 0 here. It does introduce a negative 1 and a 1. So the bottom row minus the top row is negative 1, 0, 0, 1. So I'm looking pretty good. I've got zeros here, so I already have my first two columns, finish these two pivot columns. So for this row, I want to get this to be a 0. So let's change the color once more. Maybe we'll go to blue now. I'm going to scroll down as we trace this out so that for right now I'm going to leave the top row as it is. And I'm going to also leave the second row as it is. So this is just copying down a lot of things. Being careful here not to make typos because that's unfortunate when you just accidentally copy down something the wrong way. So for the last row I'm going to do row 4, and I'm going to add to it row 3. which gives me 0, 0, 0, 1, negative 1, 1, 0, 1. So we're looking really good. Next, I'm going to go for zeros on this column. And so I'm going to leave, well, maybe do row 1 plus row 3. Or I'm sorry, subtract row 3. Let me say that one more time. Subtract row 4, because I'm going for the fourth element there. So row 1 minus row 4, which will give me 1, 0, 1, 0. So row 1 minus row 4 is a 2, negative 1, 0, negative 1. Here I'm going to do row 2 plus row 4 to get 0, 1, 0, 0, which here gives me negative 2, 1, 1, and 1. The last two rows are perfect as they are and beautiful, so I will not change those. There's only one element left that I need to get rid of in order to change this into the identity matrix on the left-hand side. So to do that, I will do here, maybe put it in yellow, row 1, and I'm going to subtract off row 3 this time. It is row 3, so 1, 0, 0, 0, 2, negative 2, 0, negative 1, and everything else copy down exactly as it is. So here we then say the right-hand side, this is our inverse matrix. We could verify that in different ways by multiplying the original matrix by this and hoping to and making sure we get the identity matrix. And that's how you would check this sort of problem. That is not required here, but hey, this is a video that you're watching because you want to learn more, so we can do that. So this is actually done, but if you want to do a quick check. So the check here, recognize that A times its inverse or its inverse times A, either one, and in fact both, should give you the identity matrix. So let's maybe just do A times its inverse to just double check that these work. So the original A, here was the matrix 1, 0, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 0, 0, 2. So there's your A. I'm going to multiply that by A inverse. And so using our format, I'm going to write A inverse a little bit higher here. Maybe I'll do it in green. So 2, and I like to leave space when I do these matrix multiplications. So in order to do A multiplied by its inverse, we're going to set it up like so, and I'll have the white matrix here be the resulting matrix. And hopefully this will give me the identity matrix. So what we're going to first multiply for this element here is this column will be multiplied by this row. So we have 2 times 1, 0, 0, minus 1. So that gives us a 1 in that element. For this next space, negative 2, 0, 1, and 1. So that adds up to a 0. This row, or this column, times the top row. Notice these are all zeros here. So the only element that's going to come out is, we can have 0, 1 times 0, 0, and 0. So we end up with 3 zeros. And then negative 1 times 1, 0, 0, positive 1. So negative 1 plus positive 1 is 0. For this next space, this column times this row, and so these are all zeros, canceling out these three elements, and this 0 and that one go away, so we do end up with a 0 here. The next column multiplies by this. So again, the only element that comes out is that third one, since these three zeros are going to kill everything else. So just this one comes out. Kill, that seems dramatic. We're going to multiply by 0. So only the third element comes out. So likewise, on this next column, this will be multiplied by 0, this will be multiplied by 0, this will be multiplied by 1, and this will be multiplied by 0. So we end up with a 0. Likewise, only that third element comes out here, which is a 0 as well. For this next space, multiplying by 1, 1, 1, and 0. So that's really going to be 2 times 1, negative 2 times 1, 0 times 1. So we're really going to add those, get a 0. Negative 2 times 1 plus 1 times 1 plus 1 times 1 plus 1 times 0. So negative 2 plus 2 is 0. 0 times 1, 1 times 1, 0 times 1, 0 times 0. So this gives you a 1. And then likewise, we'll have a 0 in this space. And then keep on going. So for the last row, we would also get a 0 is when you end up with a 2 times a negative or plus negative 2. This next space would be negative 2. The middle elements go away. Plus 2, so we get a 0. This next one, really, everything will end up being 0 plus 0 plus 0 plus 0. And then for the last column here, negative 1 times 1, these multiply by 0, plus 2. So negative 1 plus 2 is a positive 1. So this is an identity matrix, and that verifies that the inverse we found is in fact the inverse.